So, check it out. I think I can. What does it say down there?
Recording has started.
Oh, okay. I want to see if I can do this. There we go. That's what I was doing. Okay, we're going to start today with basically going through chapter 1. So if you've got your book with you, go ahead and get it out to highlight it. Or if you don't have a book, then you want to write these things down in your notebook and say, this will be on the test. Because if I cover it, if I say highlight it, then chances are you might want to learn about it. I'm moving my stuff right now, thank you. First thing we're going to talk about is statistics. That's one of those words that have two meanings. Okay? The first meaning is with a capital S. Capital S means that it is the field of studying, gathering, interpreting data. Okay? You can put it however you want to, but it's the gathering, calculating, interpreting data. What is the little s statistics? Well, the little s statistics is the parameter used with the sample. The parameter used with the sample. Now, a 25-cent word for parameter is variables. Okay? When you have a formula and it's written in terms of the sample, then you're going to have a little s for standard deviation. You're going to have an X bar for the mean, whereas if you're working with the population, you're going to have Greek letters, which we're going to get to that in just a minute. But the two meanings for statistics is capital S, the field, and lowercase s, the parameter used in the sample. And we'll get to that in just a few minutes because we're going to go over that when we get to population parameter and statistic sample. Capiche? All right. Next thing that's important, and this is how we do the first two chapters. Now, I've been through 3 books in the last 20 plus years, and every single statistics course, the first 2 units, the first 2 sections, whatever, is nothing but reading. Okay? What is a population? The population is usually the big body. Okay? The big body that you take the sample from. If you are doing a survey and you want to find out how many people are in the Marlboro Club at Tri-County Technical College, all right? Then you might use Tri-County Technical College as a population. But it takes too much time and money, which are the most important things in our lives. It takes time and money to do the whole population. So what you want to do is you want to use a sample. A sample would be maybe surveying just the Anderson campus, or maybe surveying just the the Oconee campus, which will open in the fall, or maybe the Easley campus. But the main thing you need to realize is that the sample is always going to be smaller than the what? Than the population. The population is the big set. The sample is the small set. Okay? Now, when you are dealing with formulas, graphs, or presentations about the population, you're going to be using population parameters, meaning variables. So you put parameters, population parameters, and then right beside parameters, you put in parentheses, you put variables. Okay? One of the things that a lot of people don't realize, when you take a first-year statistics course, you don't finish the course and then go out and make money as a statistician. No, it don't work that way. We're not teaching you statistics to be a statistician the day after you get out of this class. The reason we teach statistics as a first-year statistics course is, one, so you can go into another class with statistics, or two, so if you're sitting in a meeting when you're out in the real world, you don't sound ignorant by asking stupid questions that you should know in a first-year statistics course, all right? Or if you're given a presentation, you don't mess it up by using the wrong word here or the wrong variable here. So, one, to get you ready for another statistics course. Two, to make sure you know what a basic introduction to statistics is. And this is where the parameters come in. Let's say you're sitting in a meeting, and the meeting is going along, and the meeting is about finished, and the final slide, the presenter throws up, mu is equal to 35, and x bar is equal to 37. Okay? X bar is a statistic, lowercase, of the sample, because it's a letter. Mu, which looks like a backwards m, lowercase m, is a Greek letter, which is a population parameter, variable. So when you say population parameter, you put beside parameter variable. And when it says sample statistic, lowercase statistic, you put parentheses variable. When it's a population, it's going to be a Greek letter. When it's a population, it's going to be a Greek letter. So when you're sitting in that meeting, you can ask the presenter, well, I see that the population mean is a little bit off, is a little bit less than the sample mean. Why is that? Okay, you know that because the population mean is a Greek letter and the sample mean is a regular letter like X. All right? A lot of people go through statistics and they don't even know that. All right? So that's one of the things that I stress, because I don't want you to sound ignorant when you're sitting in your first meeting or you're giving your first presentation. I don't want you to sound ignorant. So the population is the big set, and any variable or any computation done with the population is going to be a Greek letter called a parameter. When you do your sample calculations, you're going to be dealing with a sample statistic, lowercase, which means it'll be a regular letter, like S for standard deviation, or X for the mean, X bar for the mean. Okay? So that's the difference between a population parameter and a sample statistic. That's what that little green box talks about. All right? Individual. I'm not going to insult your intelligence by going over the word individual. If you don't know what the word individual means and you're in a first year, I'm sorry, you shouldn't be in math class if you don't know what the word individual means. All right, I'm not going over that. I will go over this, though. Make sure you know the difference between descriptive statistics and inferential statistics. Basically, one is you're doing your own work. The other is somebody else's work. Right? Let's say that you go out and you want to find out how many people at the Anderson campus are in the Marlboro Club. How many people drive a truck, or how many people drive a SUV, or whatever you want to find out. And you go out in the parking lot and you ask 500 people, blah, 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 blah. Then you are using descriptive statistics. You are finding your own data. Versus if you go to the Department of Transportation up there on Belton Highway, off Belton Highway, and stand in line for 15 hours, and go in there and they ask you what do you want, and you say, I want to pull up the statistics for the last blah, 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 and then they look at you like a nut, and then you have to go through about 3 days of, no, I'm just kidding. And you get their records. And when you get their records, you're using inferential statistics. Okay? See, it says takes results from a sample, meaning somebody else's sample, somebody else's records. That's the way I like to explain it, because it makes a whole lot of difference. I've already covered parameter and statistic. It's up here. There's a statistic somewhere in here. Statistic. There it is. Okay. And parameter is of the population. PPSS. Remember that. Population, parameter, sample, statistic, little s. Meaning both of them are basically variables. Are the formulas the same for the population and the sample? Yes. Then why are they different? So you'll know which one's the population and which one's the sample. That's why. One's in Greek letters, the other one's in regular letters. So y'all confused yet? Hopefully not. Very important. This will be on at least, out of the reading questions, if I was to give you 10 questions out of the 2 chapters, this is going to be 3 or 4 of them right here. Quantitative versus qualitative. If I was to go through the room, the 2 rooms, the 5 there at Easley, and the 11 here at where are we at? Anderson, okay, and say how many blondes, brunettes, and redheads we got in class. That would be qualitative. Remember the saying, quality, not what?
Quantity.
Quantity. Okay, remember that, because even though it's a different word, it means the same thing. Quality means of the person or of the whatever. If you're talking about football players, are you talking about athletes? Are you talking about models? Are you talking about people that work in a company? How many people are above, blah, blah, or I'm trying to think, how many people drive white cars? That is qualitative. Versus, what's the average weight of the employees at Tri-County Technical College? That would be quantitative. Quality versus quantity. If I'll go through and ask how many blondes, brunettes, and redheads are in this classroom, that's qualitative data. But if I ask you for the average age, that's quantitative. Make sure you know that. Just think of it like this. Well, let me ask you this, and see if you can tell me if you know the difference. If I go through and ask you for the average age, what is that? That's quantitative. But what if I ask you for your Social Security numbers? Is that quantitative or qualitative? It's qualitative. Why? Because your Social Security numbers have no what? Numerical meaning. Okay? None. I would never ask you for your Social Security numbers because, God, I don't want a lawsuit. But I'm just trying to give you, sometimes the homework or the test will try to trick you by giving you something like Social Security numbers, and if you don't have a numerical value to it, like weight or height or shoe size, then it's not quantitative data. Or age, that's quantitative. Anybody got a question on that? Make sure you know the difference between the two, and they should give you a little box on the next page. There it is. Based on some attribute or characteristic, whatever. All right, characteristic, meaning eye color. What is the most popular eye color? Period. Anybody want to guess? Brown, of course. Now, what is the least? Green. Green, 2%. 2% of the population, whether you're talking about, I read it somewhere, I was reading something. I don't read very much because I'm not a reader. I'm a visual learner, I'm not a reader at all. That gum newspaper puts me to sleep and I can't even read but one article and it'll put me to sleep, so I can't even think about reading a book. But anyway, the brown eyes and then blue eyes I think come in second, and then hazel comes in third, and then green comes in last. And then you got the weird colors where one's blue and we won't talk about those. But anyway, the whole point is that's qualitative data because there's no numerical, there's no numerics, there's no mathematical value. Quantitative provides numerical measure There's the key word. If you want to highlight any word out of there, you'd highlight measure. That is also, and the next thing that's going to come up, is that word right there is critical in the next vocabulary words we're going to come up with. And that's discrete versus what? Continuous. I guess. Unless if you did your, yeah, there we go. Dang on right there. Discrete versus, now, I want to take a minute and I'm going to write something here on the board for you. Some of you might remember in algebra, that's a long time ago when you had algebra, the teacher talked about irrational numbers and rational numbers. And if I was to ask you what's the difference between the two, I doubt very seriously that anybody could tell me. Why? Because it's one of those things you regurgitate. If you did memorize it, you lost it just as soon as you got out of the test. All right? But if you think of it as rational, what's a rational number? A rational number could be like 4 over 2. It could be like 0.66 with a line over it. It could be 7. Okay, what does all of those things have in common? Well, you can't say one's a fraction. They're all fractions because they're not. You can't say all decimals are not. You can't say they're all whole numbers are not. That's not true. You know that, so don't even say that. What does all of them have in common? 1. You can predict the next number. What do you mean, Hubert? What's 4 divided by 2? 2. What's the next number? 0. 2.0. What's the next number? 0. Because 2 will go into 4. 2, you can predict it. You can put it on a number line. All right? You can predict the next digit of 4 divided by 2. You can say, okay, 2, what's the next digit? 0. What's the next digit? 0. I mean, that's not a decimal, but you just keep putting zeros. You can predict the next number. How about 0.66 with a line over it? What's that next digit? 6. What's that next digit? 6. You can predict it. What about 7? 7.0. You can predict it. You can put it on a number line. So write predictable, or write predict or locate. You can predict or you can locate on a number line rational numbers. And if you can predict and locate on a number line rational numbers, what do you think irrational means? That's not rhetorical. I want y'all to answer me. Okay? Unpredictable, or you cannot what? You cannot locate it on a number line. What the heck are you talking about, Hubert? How about the square root of 7? Some of you that's on the calculator drill team in high school, take the square root of 7 and tell me what it is. Tell me what the calculator says. Somebody take it on your calculator. Y'all got calculators, right? Some of y'all don't go to the bathroom without a calculator, so get them out. And take the square root of 7 on your calculator. Tell me what it is. I'm waiting.
2 point. Do you want me to like round this?
I want you to go all the way down.
2.64575131.
Somebody tell me what that next digit is.
It don't keep going.
You can't. Why? Because you don't see a what?
Pattern.
You don't see a pattern. If you want to put a pattern up here. If you want to put pattern, you can put pattern. You can see the pattern with this one right here. Is there a pattern with 0.666 with a line over it? Yes. The next number will be a 6. Or you could say it rounds up to 7. But this one, no pattern. So therefore you can't technically locate it because your pencil would be jumping all over the place because of that last digit. Because you don't know what it's going to be. Okay? Pi. Somebody put pi in your calculator and hit equals. What's pi equal to? 3. 3.1419. Is it 19 or 179? Which one is it? I'm sorry, what? 3.14 what? Okay, you hit pi and then you hit equals what?
141592654.
Okay, go back. Start over. 3.14 what?
3.141592654.
Okay, somebody give me that next digit. No, you can't because you can't see a pattern. That's the difference between rational and irrational. Now, what's the difference? Why are these two the same as this? Because a continuous is a measurement. Let's say I send everybody out in the parking lot, and I've got a whole box of measuring devices right here. Okay? What do you mean measuring devices? So I got a tape measure. Then I got a tape measure that reads a digital readout because you can't read a tape measure. And then I have a yardstick. And then I have a tape measure that's made out of cloth. And then I have a tape measure, you know, the carpenter's tape measures that flip, you know, fold out. Got one of those. And I've got a whole box of these. And I hand out one different one to everybody. In other words, nobody gets the same, or well, there'll be some people get the same. And I send you out in the parking lot, and I tell you each to give me a measurement on the fire hydrant that's in the middle of the parking lot. I don't see one right now, but I know there's one out there. There it is right there. All right? And I tell you to go outside and measure that fire hydrant. Tell me how tall that fire hydrant is. How many readings will I get? Let's say there's 11 people here and 5 people here, 16 people here. How many different measurements am I going to get? Anybody want to take a stab at it?
16.
I'm going to get 16 different measurements, or at least 10 different measurements. Why? One, several of y'all ain't going to know how to read measuring tape. Okay? So when it says 32 inches and 5 little marks, you're just going to say 32 inches. All right? So some of y'all don't know how to read the measuring tape. All right? Then some of you, mainly the females, you're probably going to go out there and you're going to say, he's going to measure the fire hydrant, so we need to see where the fire hydrant meets the water pipe. So that's what we need to do, because most of you females are more detailed than a male is. Okay? Male's just going to go out there and measure the red part. Okay? But the females will dig down, maybe, pull the pine needles or whatever's out there, and see, okay, there's the red part, so I'm going to measure from the red part. So there's 2 different measurements. One from the red part up, and then one from the pine needles up. Okay, because some of y'all are lazy and aren't going to even look down to see how far it goes. Does everybody see where I'm getting with this? You're not going to give me 36 inches. Everybody in here is not going to give me 36 inches. So therefore, a measurement cannot be consistent. If I tell you to go outside and measure that oak tree out there, okay, I'm going to get 15 different measurements. If I tell you to go outside and pour me 1 quart of water in a jar out of the spigot, half of y'all will give me 3/4 of the jar, half of you will fill it up to the top, half of you will get between the inch down top, you know, like you get at the store when you buy a drink. There's a little part that doesn't have the drink in it. All right? Some of y'all do that. Whenever it has to do with a measurement, meaning what? Volume, weight, distance, what else? Area. Anything measured is going to be continuous. Now, I don't know how to make that more simple, but y'all will miss it on the test. I don't know why. There's 16 people in here, 5 of y'all are going to miss it on the test. I don't know why. The question says you're going to measure the height of a tree, and y'all will put discrete. And it says measure. I don't know what else to tell you. What's the opposite of measuring? What do you do when you want to know how many eggs you got?
Count.
You count them. The opposite of measuring is counting. Counting is discrete. Counting can be located on a number line. And now you know the difference between rational and irrational, discrete and continuous. If I tell you to go outside and count, first I got to give you the definition of a white car. A white vehicle. White means the absence of any other color. Okay? So, if I tell you to go out and pick a white car, or how many white cars are in the parking lot, you would go out and count. And most of you, once I gave you the definition of what color I'm wanting, how many of the same number will I get? A whole lot more than the measuring. If I tell y'all to go to Vilo and tell me how many eggs are in a dozen crate, you'll tell me, all of you will tell me 12. And that's discrete. Anything that you count is discrete. Again, I don't know how else to make that simple. Count, discrete, measure, but I'll get 5 of y'all that miss it on the test. Okay? Next one. And I don't mean just in here. I mean any class. I don't know. I don't know why. Maybe I'm just a terrible teacher. That's probably it. It's my fault. Blame me. I'm gonna blame the Russians. So I've already done that one time today. You didn't turn the TVs off in the... No, I did. I did. It was the Russians. All right. The Russians turned them on. Okay, that's just another page about what we've gone over. Go ahead and write this page down. Whatever page. I can't see page 9. You don't necessarily have to have this for tests, but I think it's something that you might want to know for other classes. Okay, so this is just for your information, but it's not that important for a test. Nominal, ordinal, interval, and ratio. Now, on the next couple of pages, they're going to give you good examples, and I suggest you go with those examples. But this is the different types of measurement. Okay, if I was to tell you that I went to the Kentucky Derby 2 weeks ago and bet on several horses, but the first 4 horses were blah, 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 blah. What type of measurement is that? It's ordinal because I gave you a certain what? Order. So for the second one, you just go order. Ordinal means order. Nominal. There is no reason to be the arrangement. I think it has to do with. Yeah, no, you don't have to put it in a specific order. You could say, do you have to put your test scores in a certain order for you to get your test average? No. So that's nominal. Interval level of measurement. The key words you need to highlight there, just so you know it for other classes. A value of 0 does not mean the absence of a quantity. And then ratio, it says a value of 0 means the absence of the quantity. And when you get to the next page, we'll talk about that. And you don't have to write every single word. You can just put page 9 and just write the 4 measurements. We'll go ahead to the next page so you can write down examples. They should. Okay, there we go. There's 4 examples. Gender. Nominal. Does it matter whether you put gender in any type of order? No. The outcome's going to be the same. Temperature is interval. And read this next statement. Okay? For example, 60 degrees Fahrenheit is not twice as warm as 30 degrees Fahrenheit. And so that's why I bring this up. When you get into chemistry, you're going to be talking about temperature. got to remember, temperature is interval. Number of days during the, I'm sorry, I didn't see. Of course, D, what would D be? You know D would be what? Ordinal, because it's in what? Order. A means good. F means failure. You a failure. Oh my God, somebody's phone is going off. I'm supposed to have a fit. All right. Number of days during the past week that a college student studied. Well, that would be 0. I'm sorry. That would be absolute 0. Why? Because if I tell you I've studied 0 days, that means I have not studied what? At all. So what would that be? That would be where 0 means what? Nothing. So that would be what? Ratio. Oral Horatio. So you need to remember those 4 examples right there, because those 4 examples you don't understand the. Don't come back to class. Leave. I can't handle a phone going off in my class. I'm just kidding. You ever had a teacher go into hysterics because your phone goes off?
Yes.
Y'all ever had a teacher like that?
Yes, we have.
I think they need a life. Or a girlfriend or a boyfriend or both, maybe. I don't know. They need something. They need a drink or a life, one of the two. Okay, so that's 1.1. So there's about 7 or 8 things in there that you need to know about. Let's go to 1.2. Some of these sections are long, some of them are short. That's why I just go ahead and tell you to read about them. I'm not really concerned about the homework. I'm more concerned about whether you know the certain things. Let me go. No, you know that. The reason sometimes I go through these things, I get used to a certain book. Let me move my walker up here. A certain book, and then as soon as I learn the book, guess what they do? They change the authors. So you have to relearn the next book. So, all right, observational study. You ever seen those videos of people in a sleep apnea type of observation where people, they got that green and black light, or a camera, the what is it called, night vision, and they watch these people sleep during the night? You ever seen those? Okay, what is that? That's an observation. Okay, so what you need to do is put sleep apnea. When you watch people sleep, and it's funny, because some of them, they already look like a demon anyway because their eyes are black, and they got this green, and it looks like a demon anyway, and some of them just wake up and just sit up, and then they turn their head 360, they turn their head left and right, and then they just go back to sleep. And some of them get up and walk around. You ever seen those? That's an observation. Why is it an observation? Because all you're doing is what? Watching. Okay, some of y'all use it for amusement. Some of y'all, dang old pervs, dang old watch other things. Okay, but the whole point is you're observing. You're not interfering with what you are observing. As soon as you interfere, as soon as you input, as soon as you interject or inject yourself into the observation, it turns into a what? Starts with an E. Experiment. So that's the difference between an observation and an experiment. So, a rat in a maze, is that observation or an experiment? It's observation. When does it become an experiment? When you put cheese in the maze. That becomes an experiment. The observation is watching the rat in the maze. Sleep apnea. You watching the person sleep. Okay? Sleep apnea would be in give them 3 shots of Jack Daniels before they go to sleep. All right? That would be experiment versus observation, or giving them, some type of drug before you watch them. That would be an experiment. So that's a good thing to know because you might be asked that on a test. And it's also, some of these questions I've also gone over, some of you nursing students, you take these tests to go into clinicals and stuff or whatever, some of these things that I'm covering are always on those standardized tests, especially experiment versus observation, discrete versus continuous, quantitative versus qualitative. Those types of things are going to be on those tests. Capiche? Comprende? Okay. If I skip it, that means it ain't that important.
Bigger. Yeah.
Say again? Uh-oh, Brian's in there. Something went wrong. What's gone wrong?
We're going to move their screen over. For some reason, they just seen a very little screen.
Okay, that's what I was talking about in my email. That's what was happening in the speech course. I meant not the speech course, the psychology course. So I sat in the course this morning, and I had to move those over.
Okay.
Did you
we got to move over now so they can see you now.
Thank you.
Okay, well, that might not be a good thing, but at least they can see the other students. Thank you, Brian.
Yes, sir.
Okay. Let's see.
Yes, thank you.
Not going over that. The more we skip, the better until we get to the math. Okay, I'm not going to tell you what a census is, because most of you are above the age of 20, and you should know what a census is, considering that you've been through 2 of them within 20 years. So I'm not going to go over that, but that's what it is.
You're not 20, are you?
They told us this year that in the oncoming census that you're not supposed to tell if you're here illegally or not. That offends people. What's the whole purpose of the census? To gain what? Information. But you're not supposed to tell if you're here illegally or not.
Who would want to?
United States of Buttercups. All right. 1.3. 1.3. Oh, did I skip the beginning? I guess I did. Let's see. Okay, simple random sample. Let me tell you what a simple random sample is. This is one of those questions that are on standardized tests. I don't care what field you're going into. A simple random sample. If I was to take every one of your names and put them, well, let me go back. If I was to go and give every one of you a yellow Post-it note, a yellow Post-it note, and give each one of you a red pen, and give each one of you directions to print your first name, middle initial, and last name on the Post-it note, fold it in half, and put it in a goldfish bowl. Is that a random sample? And I'm going to pick somebody's name out of the goldfish bowl. Yes, that is a random sample. Why is it a random sample? I can't hear you. All I heard was Okay, volume and articulate. 2 things when you speak. Yes, who said it?
You have no control over who you pick.
Okay, you can look at it like this. I don't have any control over who I pick, or, that's correct, or you can look at it like this. Every person in the bowl has a what chance of being picked? Equal. You need to write down both of those. I don't care. Both of them are correct. I have no control on which one I pick, because all of them are written in what? Red ink. All of them are written first name, middle initial, last name. All of them are printed, and all of them are written on the same size paper, folded the same exact way. Okay, let's say Elias, right? Is I say it right? Elias? Okay, let's say Elias is a rebel and he don't like to do anything he's told, right? And he picks out, he's got a set of pink Post-it notes in his bag, and he picks out a black magic marker, Sharpie, and he writes just his first name on it, and he folds it 15 different ways and puts it in the bowl. Is it a random sample now? No. Now, some of you may say, well, it's still a random sample. He's still got one name in the bowl. Yes, but the person is picking the name. What could happen because he used a pink one and he folded it different? There's 2 things that could happen. What is it? The person could be inclined to pick it because it's different, or the person can what? Go away from it because it's different. You've affected the outcome, therefore it's not a random sample. That's why everything in statistics has to be what? Neutral. All right? Now that's where we get into a lot of stuff about statistics. Because, and a lot of people say, I'm not trying to do anything. If you take it that way, that may be because it might be that way. I don't know. But there's two words in statistics that stick out. One, neutrality. The other one, bias. Now, you're going to see both of those somewhere in this chapter or the next chapter. I don't know. But those two words go together. Why do they go together? Because they're opposites. What is neutral? You don't have a dog in what?
Fight.
You don't have a dog in that fight. You got good parents who taught you this thing. All right? You don't have a dog in that fight. Meaning that you are conducting the statistics. You are conducting the surveys, but you care less how the outcome comes out. Is that good or bad? That is very good. What is bias? Favoritism. It's me going across the United States. I went across the United States and I surveyed across the United States and I found out that candidate B is going to be the next president of the United States. But what I didn't tell you is that I started in South Carolina. I went to Georgia, Mississippi, Alabama, Louisiana, Texas, New Mexico, Arizona, and California. Did I go across the United States? I think I did. I think I hit every state across the South, right? But I went across the United States, did I not? Okay, I didn't say I went to every state, did I? I said I went across the United States. Now, what does most of those states have in common? They're in the South, but what else do they have in common? They're mostly what? Conservative. All right? Did I show bias or neutrality in that survey? Bias. I picked only people that voted or think the same way I do, or whatever the case may be. Now, I use politics, and I've gotten in trouble because of this, because I use politics for bias and neutrality during a presidential election. And I got somebody complained. Okay, what else am I supposed to use during a presidential election? The color of puppies outside? I mean, I'm sorry, I'm a teacher. I'm going to use the presidential election whenever it comes up. I'm going to use it if I'm teaching statistics. So, crowd you want, I'm sorry. I told them, I said, I'm sorry, I'm still going to do it. They, oh, well, you shouldn't use politics all the time. Only use it during the presidential election. Anyway, whatever. If I used it for another candidate, it would be okay. But anyway, the whole point is you can use neutrality, and that will help your experiment. Or now, as a presenter of helping. What if you are sitting in the audience? Can you pick up on neutrality and bias in a presentation? Yes, you can. By the way that they show the graphics, by the way that they show the samples. What about in a survey? The questions. Yes. There is a whole course. Okay, I need to easily, I'm sorry, but ever since he came in, the only thing I can see is one person at Easley and a door. Okay? So I need you to turn that camera a little bit to the left or to your right, please.
You don't have to talk in the
Yeah, I think so.
Okay, well, it might switch, it might not. So somebody count to 10 real loud. Okay, there you go. Do the clapping thing. Okay, there you go. All right, can y'all see us? Can you see the Anderson campus okay, or do you see the door over here? Which one is it? Okay. I think when we get the other rooms at Easley and the other campus, Pendleton, when we get those rooms finished, the camera's going to be on the other side of the room like that one, and the teacher's going to be on this side of the room. So when the teacher moves, you're still going to see them. But up there, it's messed up. Anyway, that's the conference room, and in Pendleton, it's a conference room, so that's why it's not a classroom. All right, I'll shut up. The whole point is, when you are given a presentation, you can see the bias, or you can see the neutrality in the graphics, in the presentation, if you're paying attention. Now, if you're going to sleep during it, then you're not going to be able to tell anything. There's a whole course at Clemson or at any other college. If you're taking a research class, like if you're going for your master's and you're going to do a dissertation or you're going to do a study. I did a study, and it was on high school students being prepared for college. And I found out that 74% of the area that I was doing, students were not ready for college courses. Okay? When you take a survey, or when you create a survey, you cannot lead people into questions. Okay? You cannot just put these answers for your questions. Why? Because that is leading the person that's filling out the survey. So you have a whole course on nothing but just the survey. It is I think that is probably the most important thing that the presenter or the person that's watching or reading the results to understand. If you don't have 100% neutrality in the gathering of the data and the interpretation of the data is not worth squat. It's not. And that's why a lot of people really talk about this bias thing, because if you think about it, in a way, I don't care if you're talking about a survey here in the classroom or you're talking about multi-million-dollar presentation at a company. You're basically lying. Okay? That's what you're doing. I know people don't like to hear the word liar. Okay? They say what? Untruth, or they say fabrication. All right? But if you take data and you skew it a certain way, you're lying. Period. And that's that's why they have a whole section of bias versus neutrality. Okay? So, and it can be the other way. Can a person sway the outcome of a survey, and their brother is the CEO of this company, that if this company goes a certain way, they're going to use that company over here product? Yeah, it can also be swayed that way. Not only just for things that you're thinking about, but it also can be for monetary gain. And that's why it's so important. So you need to be able to pick up on stuff like that. There's different kinds of samples. There's simple random sample. There's cluster sampling. And it's going to be somewhere on the next couple of pages, somewhere in there. I'm not going to go over that part, but you're going to see the different types of samples. Eventually, there's cluster sampling. It's probably in the next section. There's convenience sampling, and then there's stratified sampling, and then there's pattern systematic sampling. It's probably going to be in the next. Yeah. Stratified. I was hoping they had a list. Somewhere on here they have a list. Just let me find it so it'd be easier for y'all. Hold on just a second. There it is. Okay, they don't have all of them listed. Okay, we'll just go from there. There's random sample right here. There's stratified sampling, which means grouping. Systematic sampling. Now, if you want to know the best sample besides a random sample, it's a systematic.
32, 34.
Say again? Page 34. A systematic sample is where you go through the phone book and you pick every person in the lower right-hand corner of the phone book on each page. That would be a systematic random sample. You don't know who it is. You just pick every person in the lower right-hand corner, or you pick every fifth person, blah, blah, blah. If I was to stand outside and take a survey on Anderson campus students, I stand outside the front door because there's no other way out, and I say, every fifth person, I'm going to ask them if they drink alcohol, or if they drink coffee in the morning, or whatever the case may be. I say systematic. So if you're going to use a very neutral approach, these are the two to use. Systematic and random sampling. Now, let's say that you want to predict how South Carolina is going to vote in the next election. All right? And you want to try to get that information to someone before the election is over. So you go to a cluster sample and a stratified sample. A cluster sample, I would go to a voting precinct. And let's say, I think, what is it? There are 48 counties. Is there 48 counties in South Carolina or 46 counties in South Carolina, something like that? I think it's 46, but I can't remember. But I'm going to use Anderson as the sample. And I go and I pick 10 voting precincts in South Carolina. Right? That's called a cluster. That's called a cluster sample because I went and I picked clusters because they're people that vote. What do everybody have in common at a voting precinct? They all what? Vote. Thank you. For some classes, it just melts them down when I ask that question. They think they all drive. Yeah, they all drive. But what do they all do once they get to they vote? Okay? Now, if I want to stratify that, I would go in and change it not to just the voting precinct, but I would go inside the voting precinct and change it to Democrat, Republican, and other. And that's called stratified. It's where you go into a group and you make a subgroup into it. Okay? So, why do I really not go into stratified and cluster? Because you probably will never go into those unless you go into psychology or unless you go into biology and go into those two fields where you have to do a lot of stratified and grouping type surveys, and I don't think you'll ever have to do that. If you stick with these two as a presenter and somebody watching a presentation, those are the two right there that you're going to see most of. Capisce? Comprende? See? All right, what section is that? What was that? Is that 1.3?
1.4.
1.4. Somebody look. There it is. There's a whole section on bias right there. I think this is the last section. Somebody looked in your outline. Oh my gosh, you actually did what I told you to do. I'm not used to that. Somebody actually did what I told them to do. They took their notebook and they put the outline on the outside. I'm very impressed. What does chapter 1 say? 1.5, that's the last one. Bias. What is bias? Bias is when you sway the outcome because of your belief or your support. You may be wanting to support your brother who owns that company over here by making this company by saying, y'all putting out a lot of bad blah, blah, blah. Y'all may need somebody to come in and help with your blah, blah, blah. And my brother over here, he has this company that does this. Okay? That would be bias. And just like one of the biggest things, and we're going to get into this with probability, is the large number theory, or the large number rule. And the large number rule basically says, if you're going to put your butt out on the line, you better not be lazy. Okay? If you're going to present probability or statistics on a screen in front of a bunch of people and your paycheck relies on it, then you better not pick 100 samples. You need to pick 1,000. Or you need to pick 10,000. Because not only is your reputation on the line, but your paycheck and your job and your career is on the line. So I guess the best way to put it as far as the large number rule is you put into it, you get out of it what you what? Put into it. If you put in, and excuse me for saying this, if you put in half-ass, you're going to get half-ass. All right? And your employer will see it just as much as the people that you're presenting to. Okay? It's just like anything else. And the bias is the same thing. Somebody that knows what's going on, they're going to pick up on it just like that. I'll give you an example, and it does have to do with the last election, but it has to do within the Republican Party, okay? In the last election, the last presidential election, there was a debate scheduled, okay? This debate, and I follow politics real close, okay? I'm too versed in it, if you want to know the truth in it. But it was the debate, it was about the second or third debate. Jeb Bush had already been kicked out as being, he hadn't quit yet, but he was a joke, all right? He was a joke, and people had started saying he's not going to be the next presidential nominee. So the elite and the Republicans, they switched to another candidate, okay? They switched and started going toward Ted Cruz, the senator from Texas. And they started saying, okay, this guy's going to be the next president, blah, blah, blah. But before that debate, they wanted to make sure that Ted Cruz would get a lot of support. So out came a survey, okay, the day before the debate, okay? And at that time, Donald Trump was leading in the polls. Jeb Bush was like pulling 3%, so he was like a joke. So they were moving toward another candidate. This poll came out a day before the debate, okay? The two things about the poll I picked up right quick. One, you know how many people were surveyed? 300. 300. National poll, 300 people were polled. Good or bad? Bad, considering the population of the U.S. is 36 million or something like me. I don't know what it is, but it's either 36 million, 36 million. I don't know which one it is. Okay, it's a lot of freaking people, okay? 300 people is not worth the paper it's written on, unless you're talking about Tri-County Tech. You know, if you're talking about surveying the blah, 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 Tri-County Tech, 300 would be a good number. But not for a United States poll. The margin of error was 8%. On a national poll, the margin of error should not be below 3% or below. It should be 3% or below. So a lot of people saw those two things. I saw it first off. And the afternoon, the news was talking about, where did this poll come from? And it came from CBS, blah, 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 CBS polling, whatever. And the whole point was they were asking the same questions. Now, why did that poll come out the day before the debate? And why did they only poll 300 people? And why do we question 8% margin of error? Okay? What's the definition of a hit job? Anybody know the definition of a hit job? Y'all watch movies? Y'all not going to talk to me or what?
Like the target? A hit job target?
Yeah, basically that was a hit job to make Cruz get more what during the debate? Get more support. It was a hit job, and it wasn't directed toward anybody, but it was directed to help who? It was directed to help somebody. That is what you call bias. When you use a poll to either hurt somebody or help somebody, that's not statistics. That's just lying. Okay? So when you look at these national polls, whether it be, wife beaten or husband beaten or politics or whatever, look down at the bottom. And they have to put it. They have to put N is equal to blank, and they have to put MOE is equal to blank. I'm not that particular about N, but I do tell you this. If you're going to give a national poll on national TV, your N better be way up there. It better be way up there, 10,000 or above. And if you give a margin of error, it should be less than 3%. 3% or less, or I'm not even going to look at the poll because it's worthless. And it's used as a hit job on whatever you're trying to accomplish. All right. So that's what some things do. Some people do it because they don't even know any better. A mathematician works at a polling company. He writes up a presentation. He gives it to the newspaper guy right here. okay, to the graphics newspaper guy. The graphics newspaper guy has got a associate degree from BFE Community College, but he's a great graphics person, but he's only had one math class in his whole life. And his job is to put a graphic, to do all of this mathematician's work, put it in a graphic to show the difference between this and this. And he puts it in there, and it's nowhere right because the proportions are not correct. Okay? That is bias, but it's not intentional. That's just somebody not knowing what they're doing. That happens. That happens a lot with the media, when I'm talking about media like magazines and newspapers. That happens a lot. And it's not intentional. It's just, well, I don't know, some of it may be, but most of it's not intentional. They're going to show that in here. And I'm going to give you an example, and I want you to look at it to see if you understand what I'm talking about. Okay, this is all different types of bias. We're talking about the survey bias, the response bias, that type of thing. I've already talked about that, and you can read about that. I just want you to know about bias because it's out there. Here's a good example of a question. I have no idea what it asks. What is the most important problem facing today's youth in America, or America's youth today? Now, why is that an open question? Why is that a good question? Now, it has multiple answers, okay? But what is the question not doing?
It doesn't limit what the person can answer.
Okay, limit, or the other L word, which goes with bias. What is it? L-E-A-D, lead. It doesn't lead you in a certain way versus the second. What is the most important problem facing America's youth today? Drugs, violence, single parent, promiscuity, peer pressure. Why is that closed? Why is it not a good question? Yeah, how many of you went through teenage years? Every one of us. Does that encapsulate you? No. I didn't have a single parent home. I wasn't violent. I never have done drugs. I wasn't promiscuous. I guess peer pressure would be the closest thing, okay? But that still wasn't my problem. What problem did I have? I had a dad that was, no, I'm just kidding. My dad was my best friend, but he was rough. Let me tell you. Not, he didn't beat me or anything, okay? Don't get that in your head. He was just a very, what do you call it? He was stern. Yeah, stern. That's the best word. That was pretty much. But my answer is not there. So what does that mean? I have to pick one? Okay, that's called a closed question. It's also considered bias. You're supposed to give open questions that do not what? That do not lead. That is bias. Even though bias is a strong word, it's not supposed to, I mean, your feelings are not incorporated with the meaning of the word. All right? I want to get to the, I'm not looking at that. Okay, they're not, somewhere in here, they're supposed to give you pictures. Maybe it's in the next section. There's a picture of a soccer ball. And I don't know where the soccer ball is. Is it chapter 2? Where does chapter 2 start? Somebody tell me. I'm trying to put the page number in. Anybody got a page number for chapter 2?
60 and 61.
Okay, there we go. Somewhere in this chapter, evidently, you'll see the soccer ball, hopefully. A frequency distribution. What the heck is a frequency distribution? A frequency distribution is a 25-cent word for a table. If I tell you to tell me blondes, brunettes, and redheads, 10, 25, and 2. You have just made a frequency distribution. Make sure you hold your pinky up when you say it, because all it is a table. It's got two things. It's got a category or a class on the left, and it's got a head count on the right. Lord, you think a frequency distribution was some kind of big conglomerate thing. All it is a table. This is a category. And this is a head count. What's a class? Well, a class would be 19 to 24, 25 to 29, 28, 29 to 34. I don't care about it. I'm not caring about whether it's right or not. I'm not worried about that. 3, 6, 9. Class, head count. That's all the frequency distribution is. One is qualitative, the other one is what? Quantitative. That's one of those words when you see a frequency distribution, you shake, you don't know what that is. It's a table. You've got frequency distribution on the qualitative side, you got a frequency distribution on the quantitative side. It's not that big a deal. Now, there's a few things they're going to want you to know about the quantitative. One's a relative frequency. I'm not going to show you the relative frequencies like that. I'm just going to show you right here. That's the best way to figure out the relative frequency. Frequency is another word, right? You don't have to write this, but you can write the first 2 lines, okay? Because it shows you. Frequency, cross the word frequency out and put head count or count. Because frequency is a 25-cent word for count, for number. So how many bones or how many whatever back problems? There's 12 people with back problems. There's 2 people with wrist problems. In other words, get that word frequency out of your mind because frequency is just a 25-cent word for count. I see so many people, they come up to me and they say, what's the frequency? Well, how many have back problems? 12, that's the frequency. All right, then what is the relative frequency? You put the count over the total. The count over the total. What's another word, or what's a letter that depicts the total? N. In this case, N is equal to what? 30. So the first one would be 12 over 30 and multiply by 100, or it depends on if they want a percentage or if they just want a decimal. It doesn't matter. So the relative frequency is equal to the count over N. So when you see relative frequency on a test, what do you think? What the heck is that? It's the number over the total. Y'all all quiet easily? Y'all okay over there? Okay, they're not talking to us. Construct the bar graph. A bar graph, okay, there's 2 types of graphs in statistics. Y'all ready for this? There's 2 types. There's a bar graph and a histogram. Sometimes I think people just make stuff up. The histogram looks like this. 2, 4, 6, and you got one there, you got one here, you got one there, and you got one there. And this is A's, B's, C's, and D's in the classroom. And then over here you got a bar chart. 2, 4, 6, and A, B, C, D, and 6 is right here, and 3 is right here, and 4 is right here, and 2 is right here. So what is the big difference between a histogram and a bar chart? The boxes touch. That's it.
They're not touching each other. So we
They're not
said,
touching each other. Bar graph, they don't touch. That's what I mean. I think some people just make this stuff up. You ever have people you work with that have a job and it's just made up a bunch of stuff that other people don't want to do to make that job, and then they just give somebody a job? Well, I think some of this stuff is made up to give statisticians more credibility to be toward a mathematician versus a statistician. I'm sorry. To me, that's a joke. All right? I don't understand why you have a histogram. I mean, bar charts have been around for forever. And then all of a sudden, we have to have a histogram. The histogram came after the bar chart. So I don't know why we have that. But so you know, for your, what do you call it, standardized testing, that's the difference between a histogram and a bar chart. Don't y'all feel smarter? Nobody's going to talk. That's all right. I hate for people to talk to me in class. I despise it. Maybe after a while, maybe I'll tell you if I despise it, y'all start talking. But y'all want to make the class uncomfortable, that's fine. If y'all want to do that, that's fine. Pareto chart, I don't cover it, but you need to know for standardized tests, it is a bar chart, decreasing order of what? Count. So if you've got 20 brunettes, 25 redhead, or 25 brunettes, 20 blondes, and 5 whatever, you put it in order in your graphic. So it'd be 25, 20, and 5. That's a Pareto chart. I do not test you on a Pareto chart, so you might see it as a homework problem, but I don't cover it. Some things I tell you, test. Other things I tell you for your information. The for your information is for other classes as well as for standardized tests. And then there's stuff that just I don't need to go over, like individual and census. I'm not going over those. All right? But Pareto chart is one of those things for your information. I'm not going to go over horizontal bars because I think all of you know what horizontal means. I'm not going to insult your intelligence by going over a horizontal bar chart. But for this test, as well as any test, as well as other classes, you need to know a pie chart. Put the pie chart down, put the page, put the example down at the bottom. You need to know everything about a pie chart because not only is it on standardized tests, it will be on my test as well as other presentations in your future, other classes in your future. A pie chart is used a lot in presentations. A lot. And it just puts everything in a 360-degree circle. There you go. There it is. Figure 6 right there. Make sure you write that one down. In fact, I'm going to blow it up for you. There you go. And that is a good example of what you might see on the test. So those of you that don't want to write it, you can just put page 67, educational attainment. Educational attainment is a 25-cent word for how many people work here have this. How many people work here have a graduate degree? How many people here have a bachelor's degree? How many people here have an associate's degree? That's what attainment means. So if I have 2,000, let's say 1,000. Let's make it easy. I have 1,000 employees. All right? How many of my 1,000 employees have a graduate or professional degree? 120. Boom. Take 0.12 and multiply by 1,000. Why do you make them a 0.12? Well, most of you have had pre-algebra and algebra 1, so you know that whenever you have a percentage, you change it to a decimal 0.12. Okay? Not going to insult your intelligence, but I will kind of refresh your memory and knock the cobwebs loose. Okay? How many have an associate's degree if I have 1,000 employees? 100. 170, 300, 200, 120, and 120. Make sure you know how to use a pie chart. Not only for this test, that will be a question on the test. I can guarantee it. And I'll show you how to make them on an Excel spreadsheet too. Okay, that's 2.1. I want to get to that dang soccer ball. I don't know why they put it in different sections. Organizing. Quantitative data. Okay, the first thing you do when you organize any kind of quantitative data is you put it in what? Put it in some kind of order. So from ascending to descending or descending to ascending, whichever one you want to, because you've got to figure out certain things. All right? How many there are in a group. All right? Let's take this for instance. I might want to ask how many 6s are there? How many 7s are there? How many 2s are there? And I'd go through 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. And I'd say how many of each are in this group? And you'd go through and put it in order. And that's why Excel is so nice, because Excel, you can put things in order in 1 second. Okay? And when you're doing the homework and the test, I allow you to use Excel because it's so much faster than your calculator. Because you have to actually punch it in your calculator. You don't have to punch it in Excel because they use Excel through the homework and the test. So we'll get to it in a minute. And there is what they did. They went through, they counted how many, they put them in order and then counted, and then made a relative frequency. There's histogram. If you look up the histogram, it says something in here. Here it is. Last 3 words right there. The rectangles do what? Touch each other. That's the only difference between a histogram and a bar chart. Very mathematical difference. There's a histogram. 2 histograms. Okay, this is, we're going to, let me see right quick. I don't ask y'all what time class is over because y'all lie to me. So make sure some of y'all, well, summer class, I doubt summer class would lie to me, but my fall and spring classes, they try to lie to me and insult my intelligence. All right, write down some of these things. We're going to get to that. We'll go over that probably in the next class. I don't want to cover this yet because it's a little bit of math. I want to put all the math together. So I'll probably cover this right before we go into chapter 3. But go ahead and make a note. Page 76, we'll get into a little bit later, talking about lower class limits, upper class limits. We'll talk about that a little bit later. I'm trying to go over all the vocabulary stuff right now, not the math stuff. So we'll cover that later, probably Tuesday, whatever day y'all come back first next week.